Hello everyone, my name is Khaja Ahmed Ali Khan, and in this project I created an AI assisted creative coding artwork using p5.js and ChatGPT. The goal of this artifact was to explore how artificial intelligence can help generate and improve creative visual coding projects. The final result is a cyberpunk inspired particle flow field animation with glowing neon trails and mouse interaction. The particles move dynamically across the screen using Berlin noise, creating smooth and organic motion patterns. In this presentation, I will explain the project idea, how AI assisted the coding process, the prompts used, the structure of the code, the visual techniques implemented, challenges faced during development, my final evaluation of AI assisted creative coding. The main inspiration for this project came from cyberpunk visual futuristic interfaces and generative digital art. I wanted to create something visually engaging with glowing particle trails, smooth movement that tracks naturally across the screen. Instead of coding everything completely from scratch, I used ChatGPT to generate starting code ideas and help refine the animation system. My objective was to combine AI generated suggestions with my own experimentation and adjustment. The visual style focus on neon colors, motion flow, particle system, interactive mouse glow effects, abstract digital aesthetics. This type of artwork is commonly seen in music visualizers, futuristic AI backgrounds, and interactive installations. AI prompt engineering process. To begin the project, I gave ChatGPT a prompt asking for a P5GS cyberpunk particle animation. My first prompt was create a P5.js sketch with neon particle moving in a cyberpunk style background. The initial result produced moving particles, but the animation looked too simple and repetitive. The particle moved randomly without smooth flow. I then refined the prompts to improve the visual. The second prompt was add a flow field system using purling noise and glowing particle trails. This improved the movement significantly. The particles started flowing smoothly across the screen instead of moving randomly. After that, I requested more interaction features. The third prompt was add mouse interaction with a glowing cursor effect and optimize performance. This added the glowing cursor and improved rendering efficiency. Throughout the process, I learned that prompt engineering is very important. Small changes in wording produce very different visual outcomes. AI generated useful starting structures, but many parts still needed manual editing and experimentation. Now I will explain the structure of the code. The sketch begins by creating arrays for particle and the flow field. The particle array stores all particle objects while the flow field stores directional vectors that control movement. Inside the setup, the function the canvas is created using the browser's window size. Create canvas window width, window height. Then several hundred particles are generated using a loop. Each particle is an object containing position, velocity, acceleration, color values, previous position for drawing trails. The project uses object-oriented programming through a particle class. This makes the code cleaner and easier to manage. One of the most important parts of this project is the flow field system. The flow field system uses Berlin noise to generate smooth directional vectors. Berlin noise creates organic motion patterns that appears more natural than random movement. Each vector is stored in the flow field array and particles follow these vectors. This creates the flowing motion effect seen in the final animation. The The Z offset value changes over time. This allows the flow field to animate continuously, creating evolving movement patterns. Without whirling noise, the particles would move unpredictably and animation would feel chaotic instead of smooth. The visual appearance of the particle is created using semi-transparent neon strokes. The transparency the transparency creates a glowing trail effect as particle moves across the screen. The background is not fully cleared every frame. Instead, a transparent rectangle slowly fades previous frame. This technique creates motion blur and trailing effects. The mouse interaction adds another visual layer. The glowing cursor is created using multiple transparent circles. This creates a futuristic neon glow effect around the mouse pointer. The combination of flow fields, particle system, transparency, layered rendering helps create a final cyberpunk aesthetics. During development, there were several challenges. One issue was performance lag when too many particles were displayed. I solved this by reducing particle complexity and optimizing the flow field calculation. Another challenge was visual repetition. Some AI generated outputs look generic, so I modified colors, movement speed, transparency, and interaction behavior manually. I also learned that AI generated code is not always perfect. Some sections require debugging and restructuring to work correctly inside p5.js. This project demonstrated that the AI is helpful for generating ideas and starting structures, but human creativity and problem solving are still essential. Overall conclusion in this project successfully explored AI-assisted creative coding using p5.js. The final animation combines particle system, flow field, neon cyberpunk, visual interaction effects, procedural motion using ChatGPT accelerated development and helped generate creative ideas quickly. However, achieving a polished final result still requires experimentation, debugging, refinement, and personal creative decisions. These projects help me better understand generative art, procedural animation, AI-assisted programming, creative coding workflow. Overall, the experience showed both the strength and limitation of AI in digital art and software development. Thank you for watching.